The nth term of a GP is given as nth term is equals to AR to the power of n minus 1, where n is equals to 1, 2, 3. That is the positive integer. Let's look at the first term now. When n is equals to 1, you can see now nth term is equals to AR to the power of n minus 1 becomes, anywhere we see n here, we replace it by 1. So this n has been replaced by 1 here. The same thing, the n here has been replaced by 1 here. So we have first term is equals to AR to the power of 1 minus 1, AR to the power of 0. First term now become A because R raised to power 0 is 1. When n is equals to 2, n term is equals to AR to the power of n minus 1 becomes, anywhere we see n, we replace it by 2. So the second term now is equals to AR to the power of, the n here is replaced by 2, 2 minus 1. So the second term is equals to AR to the power of 1. Second term is equals to AR. When n is equals to 3, the nth term is equals to AR n minus 1 becomes, the third term is equals to AR, the n is replaced with 3 here, n here is replaced with 3, so become AR raised to the power of 3 minus 1. 3 minus 1 give you 2. The third term is equals to AR to the power of 2. The fourth term, the same thing, give you nth term is equals to AR to the power of n minus 1. It becomes the fourth term. Anyway, we see n, we put fourth term is equals to AR to the power of 4 minus 1, AR to the power of 3. But you see that something is recurring. The fourth term is AR to the power of 3. Meaning that if you want to do the fifth term now, the fifth term, it will be AR to the power of 4. If you want to do the sixth term, you can say that is AR to the power of 5. The seventh term, or we can just jump to the 19th term, is equals to AR to the power of 18. We'll be removing 1 from this as the formula denotes here. So anything they give you, even if they ask you to get the 100th term, it should be equals to AR to the power of 99. Okay, this one will lead us to the GP leading to simultaneous equation. To look at the GP leading to simultaneous equation. Example 1. The third and sixth term of a GP are 48 and 14 on number 2/9 respectively. Write out the first 4 terms of the GP. Now if you want to do this one, we have solution. The third and sixth term of a GP, the third term is this, is equals to AR raised to power 2, and the same third term is given as 48. So we'll say that AR raised to power 2 is equals to 48. That's equation 1. And also here, the sixth term. The sixth term of a GP is given as this, AR raised to power 5. And the sixth term is also given as sixth term is also given as this, 14 whole number 2/9. So you agree with me that this one and this one, they are also the same thing. So we have AR raised to power 5 is equals to 14 whole number 2/9. Now having gotten this, we have this one to be equation 2. So if you have gotten this one to be equation 2, then we'll have to solve it simultaneously. So how do you solve it simultaneously? we will say that equation 2 divided by equation 1 in this case. There's nothing bad in saying equation 1 divided by equation 2, but take in cognizance the power of r here is 2, power of r here is 5. Make sure you use you write the one with the power of r, the higher power of r first. So in this case, how we do equation 2 divided by equation 1, so that it will not be cumbersome for us. So we now have a raised to power 5 is equals to the 14 known number 2 over 9 divided by a raised to power 2, and this one will now be also divided by 48. Now we continue our work like this. This one we cancel this. This is r in 5 places, this r in 2 places. It will cancel r in 2 places. So by indices we have r is equals to 5 minus 2. 5 minus 2, because there's division between them. We apply one of the laws of indices. This one will now be equals to, so you have 128. 14 times 9 plus 2, 128 divided by 9 divided by 48 over 1. So we can continue like this. We now have r is raised to power 3 is equals to 128 over 9 times 1 over 48. When you cut this one, you have 8 over 3. So here you now have 8 over 9 times 3. So your r raised to power 3 is equals to 8 divided by 27. So in this case, you find the cube root of both sides. Cube root both sides to cancelled out 3. R raised to power 3 cube root is equals to the cube root of 8 over 27. This one cancel this, so you have your r equals to 2 over 3. So we have been able to get our r in this case. Now if you observe very well, they said write down the first 4 terms of the sequence. So we have been able to get our r. We have to get our a now. Since it's a simultaneous equation, let's look at our work here. Our a here is for the equation 1 is ar square equals to 48. We have ar square equals to 48, equation 1. So from our equation 1, we'll say substitute r is equals to 2 over 3 into equation 1. And equation 1 is ar square equals to 48. Our r is equals to 2 over 3. So you have a times 2 over 3 square equals to 48. So we have your a times 2 square is 4, 3 square is 9 equals to 48. In order to cancel this 4 over 9, multiply this one by 9 over 4, multiply this one by 9 over 4, the reciprocal of 4 over 9. So you cancel this, you cancel this. So you have your a equals to 4 here 1, you have 12. You now have 12 times 9. So you have 12, a is equals to 12 times 9 now, which is equals to 108. The first 4 terms of the GP, you can see that the first 4 terms of the GP, your a, we have known our a to be equals to 108, and our r is equals to 2 over 3. The first 4 terms is ar square, ar raised to power of 3. So T1 now is equals to our a 108. The second term which is T2 second term is equals to AR. So our A is 108 times our R is 2 over 3. So 3A1, 3A3 in 18, you have 6. You have 36 times 2, which is equals to the 72. This is our second term. The third term, you have T3 is equals to AR square, which give you 108 times R is 2 over 3. We square it. So we now have 108 times 4 over 9. So 9 divide this one, you have 1 remainder 1. In 18 you have 2. So you have 12 times 4, which is 48. This is our third term. Let's go to the fourth term. Our fourth term is equals to AR raised to power of 3. So we now have 108 for our A times 2 over 3. Everything raised to power 3. So we now have 108 times what? 8. 2 raised to power 3 is 8. 3 raised to power 3 is 27. So here we now have 108 times 8 divided by 27. Since 9 here go here 3 times, and 9 here you have 12. 3 here 1, 3 here 4. So we now have 4 times 8. And 4 times 8 is 32. So we have 32. So the first 4 times now will now be we give us 108 comma 72 comma 48 comma 32. This is the GP. Now let us look at the example 2 of GP leading to simultaneous equation. Example 2. The third and fifth term of a GP are 9 over 2 and 81 over 8 respectively. Find the common ratio, the first term. Okay, the third term now, they are telling us is 9 over 2. This is the third term of a GP, AR square. And that same third term is equals to 9 over 2. So you agree with me that AR square is equals to 9 over 2. Now let's go again. The fifth term here is equals to 81 over 8. So the fifth term, which is equals to AR raised to power 4. That same fifth term is same thing as 81 over 8m is equals to 81 over 8. Okay, so we'll now see this one is an equation 1. We do this one to be equation 2. So we have AR raised to power of 4 is equals to 81 over 8, equation 2. Now for us to continue the way we did the last one, the previous one, since this one having the power of 4, this one having the power of 2, the one that has high power should go up. So we'll say now that equation 2 divided by equation 1. So what's our equation 2? AR raised to power 4 divided by AR square. This one divided by this equals to 81 over 8 divided by 9 over 2 divided by 9 over 2. So this one cancel this. So we have our R raised to power 2 is equals to 81 over 8 times 2 over 9. You change this one when you change this one, when this one comes to times now. So you have 9 here 1, you have 9 divide this one to give you 9. You have 2, 1, you have this one to be 4. So your R now will now be equals to plus or minus square root of 9 over 4. So your R can be plus or minus 3 over 2. That is our common difference. Remember, we have to get our what? Our A. Yeah. So to get a now, to get a, we put what? Put r is equals to 3 over 2 in equation 1. In equation 1, what do you get? This is equation 1 now. Anywhere we see r, we put 3 over 2 there. Whether we put minus 3 over 2 there or plus 3 over 2 there, since it's square, the minus will go. We will still get the same answer. So a now times 3 over 2 square is equals to 9 over 2. So we have your a times 9 over 4 equals to 9 over 2. You multiply this by the reciprocal of this. So this one times 4 over 9. This one also times 4 over 9. This one cancel this, since we need only a in this side. So this is 2 here 1, this one 2 here 2. 9 here 1, 9 here 1. A is equals to 2. So this is our common ratio, and this is our first term. Example 3. Example 3. If 2, x, y, 54 are what? Are in GP, find x and y. This one you can see quite very clear. Since they are in GP, what we have to do, okay, we will write them down. The 2, the x, the y, and 54. What we are giving here. You agree with me? This one is our a, is the GP. This one is our AR, the GP. This one is our AR square, and this one is our AR cube. Now we are given this, and we are also given this 2 and 54. So our a is equals to 2 here by implication, and our AR raised to power 3 is equals to 54. You now put a in this. Put a in this. So what do you have? 2r raised to power 3 is equals to 54. Divide by 2, divide by 2. So you have your r raised to power 3 is equals to 2 in 5, you have 2. Made that 1 in 14, you have 7. So here you can say that to find the cube root both sides. Cube root both sides. So what do we have? We have the cube root of r is equals to the cube root of 27. So what's your r now? Our r is equals to 3. Cube root of 27. We are having problem with find. I think you should know how to get the cube root. Now let us get our what? And your x here is equals to AR, second term. X is equals to AR. So what's your A is 2 times what's your R is 3. So it's equals to what? 6. If you want to get your y is equals to AR square. So your A is equals to 2 times 3 square, which means 2 times 9 give you 18.